this session, I'm going to explain about the tank circuit, resonance frequency, and quality factor for this type of tank circuit. So first let me draw the tank circuit here. Tank circuit. This is voltage, resistance, inductance, and this is the capacitance. Okay, and this is the value of R, L, C. This voltage V is equal to Vm sin omega t. Because of this application of this voltage, some current will circulate I. Let us consider this current is, since it is IL, it is capacitance, it is IC. I am taking like this. Just I am representing the values of the currents in each branches like this. Now in this circuit, what I am going to find here is the resonance frequency and the quality factor for this tank circuit. I am going to find here. To find the resonance frequency of any circuit, we should find the admittances. So first let me indicate the impedance of this branch. Let us consider okay, let us consider it is Z1. Let us consider it is I1 and I2. Let us represent like this only, I1 and I2. So it is Z1 is the this branch impedance. Z1 is equal to R plus J into XL, and Z2 is equal to minus J into XC. Now what is Y1 here? Y1 is equal to 1 by Z1, that is equal to 1 divided by R plus J into XL. If you factorize it, R minus J into XL divided by R plus J into XL into R minus J into XL. So this Y1 is equal to R minus J into XL divided by, so it is R square plus XL square, and Y2 is equal to 1 by Z2, that is equal to 1 divided by minus JXC. I can write as J divided by XC. It is Y2. Now you calculate the total admittance. Total admittance of this circuit. Let us consider it is Y1 plus Y2. So Y is equal to Y1 is here Y1 is R minus J into XL, R minus J into XL divided by R square plus XL square. Y2 is J divided by XC. Now Y is equal to R divided by R square plus XL square. Let us separate the imaginary part and the real part. Here it is 1 by XC minus XL divided by R square plus XL square. Now for any circuit under resonance condition, the imaginary part of the admittance or impedance should be equal to 0. So under resonance 1 by XC minus XL divided by R square plus XL square is equal to 0. Now it is 1 by XC is equal to XL divided by R square plus XL square. Now cross multiply it, R square plus XL square is equal to XC into XL. Now it is R square plus omega L whole square is equal to 1 by omega C into omega L. Since it is under resonance frequency, it is omega naught. So this omega naught and this omega naught will get cancelled here. So omega naught square L square is equal to, it is L by C. If I bring this resistance to the right side of the equation, it is R square. So omega naught square is equal to it is L minus R square C divided by C into, if I bring this term to the right side, L into L square. So omega naught square L square is equal to L minus R square C by C. So if I bring this term to the denominator, it is L square. Now omega naught square is equal to, if I, what is this here, L is taken as common here, 1 minus R square C by L divided by C into L square. If I take L as a common here, this one L will get cancelled. Omega naught square is equal to 1 by LC into 1 minus R square C by L. So omega naught is equal to 1 by root LC into square root of 1 minus R square C by L. So it is in radians per second. It is the resonance frequency of this tank circuit. In terms of hertz, it is 1 by 2 pi root LC into square root of 1 minus R square C by L hertz. So this is how we can calculate the resonance frequency of this tank circuit. Next, let me draw this phasor diagram. From that we can find the quality factor of this tank circuit. Phasor diagram. In this phasor diagram, so first let me draw the circuit here. This is the circuit, resistance, inductance, and this is the capacitance. R, L, C. Let us consider this I1, this I2, this is I, this V. Now, while we are drawing this phasor diagram for this circuit, V is common for this element and for this element. So let us take this V as a reference here. It is V. Now I1, I2, I need to represent in this phasor diagram. I1, this current is flowing in a RL series circuit. So this current I1 lags the voltage by an angle phi 1. So this is I1 by an angle phi 1, because it is an RL circuit, current lags the voltage by an angle phi 1. It is pure capacitance. In a pure capacitance, this current leads the voltage by 90 degrees for a pure capacitance. So this will be I2. I2 will be like this. It is 90 degrees. Now, for finding the quality factor or drawing another thing, I should be drawn here. Anyway, under resonance condition, this I and V should be in the same direction. So this I will be like this. But here, same thing here. It is extend this one, this one. So let us consider this O, A, it is B, it is C. We know that, let us write this sin phi 1. Sin phi 1 is equal to AB, opposite side by hypotenuse, that is OB. And AB divided by hypotenuse is here I1. So AB is equal to I1 into sin phi 1. So this AB is I1 into sin phi 1. That means from here to here it is I1 sin phi 1. So this AB is nothing but this OC. That means from here to here it is I1 sin phi 1. As per the definition of this resonance, this should be equal to this one. That means this I2 should be equal to this I1 sin phi 1. That is I2 should be equal to I1 sin phi 1 under resonance. Now What is this I2? This voltage divided by XC. V divided by XC is I2. So V divided by XC. What is this I1? V divided by, let us consider this impedance is Z1 and sin phi 1. So here it is, we know that if you draw this Z1 is equal to, what is this Z1? R plus J into XL. So this is R, this plus J into XL, because plus J is nothing but plus 90 degrees. So it is Z1. We know that it is a impedance triangle and it is phi 1. Now for this, if you find this sin phi 1 is equal to, from this XL, if you find the magnitude, if you consider the magnitude only, not the direction, it is XL. If you consider the direction also, J into XL. So XL divided by this Z1, it is Z1. So you replace this sin phi 1 with XL divided by Z1. So this V and this V will get cancelled here. So Z1 square, if I cross multiply this, Z1 square is equal to XC XL. XC is nothing but 1 by omega naught C. It is omega naught L under resonance frequency. It is Z1 square. So this omega naught will get cancelled. It is L by C. So Z1 square is equal to L by C. Z1 is equal to square root of L by C. Just remember this. The impedance of this branch Z1 is equal to square root of L by C. We derived it. Next thing, here if you find the cos pi 1 from the phasor diagram, cos pi 1, what is cos pi 1? Adjacent by hypotenuse. OA divided by hypotenuse is OB. So what is this OA now? So OA divided by OB is I1 here. I1. OB is nothing but I1. So here OA is equal to I1 cos pi 1. And this quantity is nothing but this I. So finally the current I is equal to I1 cos pi 1. Because it is OA, from here to here, it is I1 cos pi 1. From here to here, I1 cos pi 1, this one, up to here, from here to here, OA is cos I1 cos pi 1. That is equal to I. That means it is I here. I is equal to I1 cos pi 1. Now, what is this I here? I is equal to I1. What is this I1? I1 is this is V divided by Z1, right? The impedance offered by this branch is Z1. V divided by Z1 is I1. So it is V divided by, the impedance offered by this branch is Z1. This I1 is the voltage across this one divided by the impedance offered by this one is Z1. So V divided by Z1 is I1 here. So it is V divided by Z1. Cos pi 1, same circuit. So from the sin pi 1 is equal to, it is, if it is XL divided by Z1, cos pi 1 is equal to, what is this? It is R, that is adjacent divided by Z1. So substitute here, this is R divided by Z1. Now this is equal to V into R divided by Z1 square. So I is equal to V into R divided by, what is Z1 square here? Z1 is equal to square root of L by C. If I substitute, it is L by C whole square. Now this is equal to, I is equal to V into CR divided by, I think it is L by C, CL divided by L. If I square it and bring this term to the numerator, it will be like this. Now if I write V by I ratio, if I bring this term to the right side in denominator and bring this term to the left side, it will become L by CR. And we know that this V by I, this is V by I. V by I is nothing but, this is the applied voltage to supply current. So this is indicates the total impedance offered by this circuit. So under resonance condition we are calculating this So this is nothing but Z dy, dynamic impedance, dynamic impedance of this circuit, that is equal to V by I, that is equal to L by CR. So Z dy is equal to dynamic impedance L divided by CR. This dynamic impedance is important formula for calculating the problems. Okay, Z dy is equal to L by CR. Okay. Next, the quality factor. Next thing here is the quality factor. I need to find quality factor. Quality factor Q. So the quality factor Q can be defined as it is the ratio of reactive component to the active component. What is the reactive component? Either it is I2 or I1 sin phi 1 divided by active component is I. I is nothing but I1 I or I1 cos phi 1. Right, okay. So it is this suppose if I write it in I1 sin phi 1 divided by I1 cos phi 1, this I1 will get cancelled, it is tan phi 1. What is this tan phi 1 from this? Here the cos phi 1 is this one. Tan phi 1 is, it is XL divided by, I think it is, what is that? XL divided by R. It is XL divided by R. So tan phi 1 is equal to XL divided by R. And it is equal to omega L divided by R. Since we are calculating this quality factor at resonance, it's omega naught L divided by R. So the quality factor of a tank circuit is omega naught L divided by R. But not, it is not equal to 1 by omega naught CR. That you should understand. It is not equal to 1 by omega naught CR. It is not equal. But it is equal to omega naught L by R. So this quality factor is for the series resonance circuit. Right, okay. And also we cannot write it as 1 by R into square root of L by C, because omega naught, okay, tank circuit resonance frequency is different. Tank circuit resonance frequency is this one. It is not 1 by root LC. If it is 1 by root LC, in case of series RLC circuit, that is 1 by R into square root of L by C is the quality factor. But this is only the formula for finding the quality factor for this tank circuit. Right.